Welcome. Today we are going to start the problem class. The first class is on sequence. Now let's start the first problem. The first problem is from Tifr 2019. The problem is for n greater equals to 1, a sequence x n equals to 1 to infinity such that x n equals to 1 plus 1 by root 2 plus dot 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 1 by root n minus of 2 to the power root n. Then xn is the options are decreasing, increasing, constant, oscillating. Now let's start with the solution. We have to check the xn is decreasing or increasing or constant or oscillating. So if we can say xn plus 1 less than xn, then it is decreasing. If xn plus 1 greater than xn, then it is increasing. And for constant xn equals to some k for all n, for all n, in this also for all n. For oscillating, there must be a oscillation. Let the sequence. Now let's check the sequence. Now write the sequence xn equals to 1 plus 1 by root 2 plus dot 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 1 by root n minus 2 root n. Root n. Now let's start with any xn plus x. Now let's check if it is monotone or not. Now start with any xn plus 1 minus xn. Then xn plus 1 firstly contains these terms up to n plus 1, and xn contains this term up to n. And xn plus 1 contains this term up to n plus 1. Then if we subtract in xn plus 1 from, if we subtract xn minus 1 from xn plus 1, then here one term remain, that is a 1 by root of n plus 1. And for this part there for x n plus 1 there will be root of 2 minus x 2 minus of 2 into root of xn plus 1, and here is a negative sign, so that will be positive 2 plus 2 root of xn. Now how to calculate? There is a part Now For simplifying, we multiply this term with root of n plus 1 plus root of n, মানে that is we 2, that is we multiply with root of multiply this term with root of n plus 1 plus root n, and after multiplying with this root of n plus 1 and root n, we get n plus 1 minus n, মানে that is root of n plus 1 minus root n into root of n plus 1 plus root n, that is n plus 1 minus n. N plus 1 minus n. Now this is root of n plus 1 n plus 1 plus root n, and here root of n plus 1 plus root n minus 2 root of n plus 1, and here remain only 1. Now we get root n minus root of n plus 1 root of n plus 1, sorry, root of n plus 1 plus root 10. In the lower part it is fully positive, but here as n plus 1 greater than n, then root of n plus 1 is also greater than root n, so it is wholly less than 0, it is wholly less than 0 for all n. Now the conclusion is x of n plus 1 less than x n for all n. So we can say the sequence it is decreasing. Then we can say xn is decreasing. There are just 4 options: increasing or decreasing or oscillating or constant, so we get xn is decreasing. Now let's move to the second question. For a sequence a1 equals to root 2 and n plus 1 equals to 2 to the power an by 2 for all n greater equals to 2. Then check the convergence. Check the convergence of the sequence. Now how to think? This is a sequence which is formed in recursive way. For this type of sequence we can use induction method to check something. Now let's check if the sequence is monotone or not. We have now a1 equals to root 2 and a2 equals to root 2 to the power root 2 মানে root 2 greater than 1, root 2 greater than 1, then we can say it is greater than a1. Now a2 greater than a1, here a2 greater than a1. Let am plus 1 greater than am. We are going to check if am plus 2 greater than am plus 1 or not. Then am plus 2 by am plus 1 equals to 2 to the power am plus 1 by 2 by 2 to the power am by 2, that is 2 to the power am plus 1 minus am by 2. If in am greater than am plus 1, then am plus 1 minus am must be greater than 0, so this is greater than 1. 2 to the power k, where k greater than 0 implies yes 2 to the power k greater than 1, so this term is also greater than 1. This implies am plus 2 greater than am plus 1, am plus 2 greater than am plus 1. Then from principle of mathematical induction we can say an plus 1 greater than an for all n. So the sequence is monotonically increasing. Now let's check if it is bounded or not. Clearly a1 equals to root 2 less than 2. Let am less than 2. Then am by 2 less than 1. This implies 2 to the power am by 2 less than 2. This implies am plus 1 less than 2. Then by principle of mathematical induction we can say an less than 2 for all n belongs to n. Now an plus 1 greater than an and an less than 2 for all n belongs to n. Now a sequence is monotonically increasing and bounded above, then we can say the sequence is convergent. Then this theorem is called monotone convergence theorem. Then we can say an is convergent. Let's then if then an is convergent, then limit an exists. Let limit an equals to L. Now an plus 1 equals to 2 to the power an by 2, taking limit an plus 1 n tends to infinity equals to limit n tends to infinity 2 to the power an by 2 This implies if an goes to L, then an plus 1 also goes to L, then 2 to the power n by 2. This is valid, the equation is valid for only n equals to 2. Then we can say limit an equals to 2. An is a convergent sequence and limit an equals to 2. Limit an equals to 2. Now you can prove yourself two problems. Problem number 1, a1 greater than 0, an plus 1 equals to 2 to the power 1 minus an for all n greater equals to 2. And second is a1 equals to 0, an plus 1 equals to 1 by 4 to the power an for n greater equals to 2. Check the convert